a little bit of new stuff. And we're going to learn what a matrix is. A matrix is when you put a bunch of numbers into a box. That's basically what it is. You make a big set of brackets with rows and columns, and you put numbers into that big set of brackets. And we use matrices to organize data, and one of the things that it can do is it can solve very large systems of equations easily, but a little bit annoying. You are going to have to do so much little mental math, and guaranteed that every 10 mental math things you do, you'll make one mistake, and that one mistake will cause you to be like so frustrated. So we're going to have to really try to see if we can make no mistakes whatsoever. Yeah. Good luck. Okay, so the horizontal entries in a matrix are called rows, right? If you have problems remembering that columns, I don't have problems remembering that columns are up and down, but sometimes I have problems remembering that rows go across. Because you're like, well, in the classroom, rows are going up and down. So I think of columns when I think of a building having columns, and they always go up and down. And therefore, the rows have to go sideways. So I don't remember which way the rows go, I just remember which way the columns go, and then rows go the opposite. We have the dimensions of a matrix are always how many rows by how many columns. And this is the way that I remember it. I say matrices rock. Rows first, then columns. So it kind of works, right? So when we're talking about how big a matrix is, if it's a 4 by 3 matrix, it would have 4 rows and 3 columns. Rows first, columns second. So here we have a couple of matrices, and we're going to say the order of them. And remember, matrices rock, so we say the rows first, columns second. This one would be 3 rows by 1 column. This is a 3 by 1 matrix. This is a 4 by 3 matrix. And this one has 1 row and 4 columns. We would call it a 1 by 4 matrix. Now, I know this is a little bit more difficult than the calculus you've been doing, so if you just bear with me, you'll be fine. When we're labeling matrices, we call a matrix usually with a capital letter, and then we call the little entries with a little letter and 2 little numbers to represent which row and which column. Okay, again, row is always first, column is always second, matrices rock. Sometimes, so this would be matrix A, it's an M by N, you would have A11 because this element is in row 1, column 1. This would be A12, row 1, column 2. A13 because it's in row 1, column 3. This one right here is in row 2, column 3, so we would call that element A23. And you will see that mathematicians sometimes put the comma, sometimes they don't. Sometimes they just would write this. It'd be like, obvious that the 2 stands for the row, the 3 stands for the column. You would need commas, I guess, if you got to a matrix that was so big that it had like more than 10 elements or 11 elements, because then it would be hard to tell which one's which. Okay? Oh, and we like to use I for the rows and J for the columns. And then we have We call, this is so genius. They call the numbers on the diagonal, the diagonal. It's like, again, I apologize for this being so complicated so early. So we have matrix M. If you wanted to find element M13, you would go to row 1, over to column 3, and see that this one is 0. The element in 3-4 is E. Now, do you think of that as a number, or do you think of it as a letter in this case? What did your brain go to? And M24, that's pi. So if you saw pi, you'd probably think of E as a number. But if you saw D, you'd probably think of E as a letter. Oh my goodness. So confusing. What are the dimensions, or what is the order of matrix M? How many rows? 3. How many columns? 4. It is a 3 by 4. You ready for some more complicated definitions? A column matrix has 1 column. A row matrix has 1 row. A square matrix is a square. It has the same number of rows and the same number of columns. So these are some examples of square matrices. No problem. A zero matrix is a matrix where everything inside of it is 0. But here is the first one that is a little bit different, is the identity matrix. The identity matrix has to be a square. Ooh, I wanted to underline that in a different color. Has to be a square. And on the main diagonal, this is always your main diagonal, those are always 1s. Everything else is a 0. For matrices, this is like the number 1 of matrices. We're going to find out, like, you dealt with the number 1 in regular math. You're pretty good at your times table with the number 1. This is the number 1 with matrices. When we do learn the complicated act of multiplying matrices, you're going to find out when you multiply by this, nothing changes. But we don't know how to multiply by matrices yet. It's going to be a lot of fun. The transpose of a matrix is when you just decide to switch your rows and your columns. So if this is A transpose, and A happens to be a 4 by 2, your transpose will be a 2 by 4. Row 1, which is 4, 3, becomes column 1, 4, 3. Row 2 becomes column 2. Row 3 becomes column 3. And row 4 becomes column 4. So if we took, for example, an element in A, like A42, in the transpose, that's this one, right? That's my 7. If I switch things in my transpose, that element's now into 4. So same thing in our second one. The transpose of this one, we'd have A, F, B, E, C, D. Just switching your rows and columns. You need the transpose for some higher level proofs, but we really don't use it very much. almost done the lesson. I know it's been really heavy. You're going to have to take some time to process this. But we're going to end with adding and subtracting matrices. There's a special rule for adding and subtracting. You can only add or subtract if they have the same dimensions. And then when you add them, all you do is add the corresponding elements. So for example, I'll circle this 2 in purple. Its corresponding one is this 1. All you do is add that 2 plus 1, and you get 3. How many simple mental maths do you have to do in this? 9. Is it hard? Extremely. But the hardest part is to stay focused enough that you make no mental math errors in the process of adding them all up. You'd be like, ooh, 1 and 5, 6. Question asked, do you have to show this step in the middle? That would be really annoying. Yes, you have to show the step in the middle every single time. Dropout rates for matrices would go way up. I can't do this. Subtracting is the same. And then we have scalar multiplication. Scalar multiplication is when you have a number out in front. And it's kind of like distribution. If you have a number out in front, each element inside gets multiplied by that 2. So we take, for example, this 8. If that 2 hits that 8, that becomes 16. You take this 5. That 5 gets multiplied by the 2. You get 10. Even this negative 2 gets multiplied by that. You get negative 4. So again, it is not very complicated. And that is scalar multiplication. Have you ever seen the word scalar before? Okay. It's interesting in mathematics. Sometimes we have numbers show up in different places. Scalar multiplication is just multiplication by a number in front. So scalar is another word for number. Element, in this, we talked about elements of a matrix, or just the numbers inside the matrix is another word for number. Okay, but when we have numbers appearing in special places in matrices, we start to give them different names. So we have scalar multiplication. It's just a regular number in front multiplying. And it's not very hard either. I know that you will definitely need some practice with this, so I have a worksheet. If you want to smile at it and look at it, and that's all you do, that's okay. But I will hand it out, and then you can work on it. Answers are provided, thank goodness. They have a couple on here, and I guess 7 and 8 might cause you to think a little bit.